Thanks to all for your presentation again. So we had a lot of questions during your presentation, so we'll try to answer as many as possible during the time remaining. So the first one, perhaps for Tanguy, concerning the numerical modelization when you modelize the nylon rope. A question regarding the axial stiffness that you consider for this polyamide.
Yes, so we did not. So we consider for the nylon nonlinear stiffness for the mooring lines. It was a simplified model extracted from the project Polyamour carried out by France Énergie Marine. For the polyester law, it was the SIROP models, but just for the nylon, it was just a simplified nonlinear stiffness law. And I can see that there is a question about in a comment for this question if we consider creep and the seabed clearance. So no, we did not consider creep. That is, of course, an important subject when you look at synthetic ropes. And we did not as well consider the seabed clearance. So the idea for all the mooring design is not to define a design that can that is at the level of detail that can be installed, but to have a robust enough design to be compared between shared and unshared. And the hypothesis behind that is that you have the same hypothesis for the comparison between shared and unshared mooring. So what is done here is that we consider that the seabed, for example, clearance can be handled with buoyancy or a socket or whatever, but it is the same hypothesis for both designs. Hope it answered the questions.
Okay, thanks Tanguy. Just to add a few words regarding the complex behavior of polyamide and synthetic fiber. So we also conduct some GIP project at France Énergie Marine to address this complex phenomena by considering a better or to more precise law to better modelize the visco-elastoplastic behavior and the creep effect also and the aging phenomenon. Another question for you, Tanguy. It is appropriate to consider mooring line factor loads, mean coefficient and dynamic coefficient for hybrid line?
Well, to my knowledge, yes, I think so. It's possible to do that. Of course, if you have different sections with different MBL, you have to compare this criteria with the respective MBL for each section of the line, but I think it's okay to do so, yeah.
Okay. Alors, perhaps another question for Gustave Eiffel University. Could you please, Mathieu, Ricardo, or Christelle, clarify where the load was applied onto the pile during the test?
Yeah, Ricardo showed a small picture where the cables, the lines, the mooring lines are located about 0.5 D above the mud line, so that this is where the load is applied globally. Okay. And we can't do any better because of the thickness of the mooring lines, basically.
Okay, another question regarding the geotechnical aspect. The displacement of the anchoring pile could create singularities that will trigger the scoring process. Has this been studied or anticipated or neglected?
Well, in this case, it's neglected because studying scouring processing in the centrifuge is very complicated. You will need a wave generator that's embarked onto the nacelle and spinning at 100 G. That's a whole project altogether. So unfortunately, we can't study the development of scour as we pull the pile. To my knowledge, this has not been done on the centrifuge ever by anyone. It can be done in a flume tank on specialized facilities like the one in HR Wellingford, for example, but it can't be done on the centrifuge as of now. Although it's a very interesting phenomenon, I agree.
Yeah, for sure. Thanks, Fidel. Very clear. Okay. Thank you. So another question regarding the economical presentation, to have for Caroline or Tanguy if you want to complete. So you present analysis on drag anchor, and you consider drag anchor as a share anchor.
No.
No,
Drag
okay.
anchor is only non-shared anchor. It's just I compare non-shared drag anchor with shared pile anchor.
Okay.
Yeah.
Yeah.
Okay,
And
clear.
we,
Because
yeah, we agree. It's impossible to share drag anchor.
yeah. Okay, in line. Okay, again in the economical presentation, you present that install pile cost in deep water were lower than drawing anchor. Could you please explain further the assumption in the cost estimation?
I didn't consider a variation of installation for each deep water cases.
Yeah, okay.
For each water, it's the same installation time for each water depth. It was an assumption. So the variation it should be the same installation. It is the same installation cost. The only variation is the installation time for each anchor type for installation. It is independent on water depth.
Okay, at this stage, this is an assumption to not consider the variation of the cost due to the water depth increase. Okay. Okay, thanks. Just perhaps to clarify another question. This is what is cable in the mooring line cost comparison? It is Y cable, I think. It's not the dynamic electrical cable.
No, it's not. No, I think it's maybe
it's a Y cable.
Yeah, okay. It's a steel wire. A wire cable. Yeah, yeah. It's a mooring. It's not dynamic cable. It's steel wire, I would say.
Okay, thanks. Tanguy, perhaps just to clarify the conditions that you use for accidental load case analysis, 1 year, 50 years return period, or other?
It depends on the type of ALS studied. I can come back quickly on the slide if you want.
Yes, please.
To answer that. Just a second. So it will be here. Yeah, so we based into the NV recommendation, and so there is several cases in ALS, extreme cases when we applied a combination of 500 return period wave with 1500 return period wind, and the opposite, 500 wind and 50 years, waves. So this is one ALS cases, and for transient condition and failure condition, it's 50 years return period conditions for wind, waves, and currents. But the coefficient applied for check are easier to pass. As you can see here, the coefficient beyond the tension are easier to pass. This is where it becomes easier.
Okay.
Hope it answered the question. So 50 years more or 500 years.
Okay, thanks, Tanguy. In the same way, could you just clarify the way that you use to optimize the mooring footprint?
So for the mooring footprint, I did not.
Without anchor chairing, in fact, and if drag embedded anchor are used, no anchor uplift can be expected. So for the pile, you consider also perhaps to the capability to have an uplift a little, an angle.
Yeah, so this was not considered in the optimization. So in the optimization on the mooring lines specifically, we just consider a fixed point on the bottom. So I agree to do a precise optimized design. You have to include the type of anchor you're using. So pile anchor, suction anchor, drag anchor. But in our case, it was not the case. It was just a fixed point at the seabed surface. So not considered. the cost optimization is so it's a cost optimization just on the material of the mooring lines, including the connectors and the tensioner, plus the criteria mentioned before, so the offset, the tension on the lines, and that's it. And the parameter are the MBL, the line length, and the type of material we can choose for the optimization, but no consideration about the type of anchor specifically.
Thanks. Perhaps a general question. So for the share anchor layout is relatively shallow water. Have you considered the potential of extra cost, of cable routing to avoid mooring clashing?
And no, so I think you consider a dynamic cable. So no, we did not include the dynamic cable into the layout optimization or the mooring optimization. The idea behind with that is that we consider that for shared and unshared configuration, this is the same problematic. So in the comparison, you will have similar cost comparison, and so no reduction, for example, or increased in the shared system with for the dynamic cable, because the anchor are placed at a similar place on the seabed. Even it can be reduced in case of unshared anchor, but still the risk of clash between the dynamic cable and the mooring lines is still the same, and this is not the point of the study.
Okay, thanks. Well, it's almost the time to conclude, but before, just few words. But thank you again for all the partners for your participation and for your also answer to the question. So as Tanguy already said, France Energy Marine and its partner will continue to work on this subject, and we propose a new GIP before the end of this year. So we're looking for additional partners. Do not hesitate to contact us if you are interested about this subject. I also inform you that this presentation will be available on France Energy Marine website and also on our usual communication channel. So yeah, thank you again for your participation. Thank you to all the partner speakers today, and I wish you a very nice afternoon.
Thank you very much, Nicolas, and everybody.
Thank you.
I see just a last question, Nicolas.
Yeah.
I think it's an interesting one that about the margin left in the ULS utilization factor ratio. So there is no margin left for the ULS utilization factor, so it's up to the limit, and so it's possible that if we include fatigue analysis, we had to consider that. And for the transmission of the fatigue to the pile, it's not considered because we think that, and it is a recommendation from geotechnical point of view, that the anchor design is governed by extreme event and not by fatigue analysis. So we did not implement a methodology for site combination for fatigue analysis at the pile. That would be it.
Thank you, Tanguy, for this additional.
For the last comment.
No, thank
Sorry
you.
for that.
Thank you to all.